In this video, you will learn how to input data, make a scatter plot, and find the line of best fit by calculating the linear regression. We will use data taken from the world of nature. The following data shows the relationship between chirps per second of a ground cricket and the corresponding ground temperature. The first step to finding a linear regression is inputting the data. To edit your list, press Stat. Edit and number 1 will be highlighted. Press Enter. If there is already something in your list, you will need to clear them out. To clear your list, move to L1 using your arrow keys and hit clear and then enter, and you will notice that all of the data will be deleted from list 1, and if you have data in list 2, you will need to go ahead and clear that out as well. Now you are ready to input your data. The default on the calculator is to put the independent variable in list 1 and the dependent variable in list 2. Therefore, we will put the temperature in list 1 and the chirps per second in list 2. Pause the video and input your data. Now that you have the data inputted, you can make a scatter plot. You will want to determine an appropriate window. Look at the temperature values. They go from 69.4 to 93.3. I will choose my X min to be 60 and my X max to be 100. Go ahead and make my scale to be 1. The chirps per second range from 14.1 to 20. So I will choose my Y min to be 10 and my Y max to be 25. All of my data should be included in this window, and if I find that it doesn't, I can just adjust my window later. To create this scatter plot, go to Stat Plot by pressing second Y equals. You can choose any of the stat plots here, number 1, number 2, number 3. I will choose number 1. Press Enter, and you will want to make sure it's on. If it's off, as most of them are by default, then you'll want to just use the arrow key to make sure that it's on. You will notice some different kinds of graphs under Type. Here's a scatter plot, a line plot, a histogram. These are box and whisker plots, but the scatter plot is highlighted, and that's what I want, so that's fine. As I mentioned before, the default on your calculator is to have list 1 as your independent variable and list 2 as your dependent variable, and so my lists are appropriately set, so I'm fine there. Then it's going to mark it with a little box. So to graph your scatter plot, all we need to do is to hit Graph. Your scatter plot will appear. Now to graph your line of best fit, you will need to find the linear regression. Press Stat and use the right arrow key to move over to Calculate. Use the arrow key to go down to number 4 for linear regression, or you can just hit 4 on the keypad and it will go down to number 4. You might notice that if you continue to go down, that you will find number 8 is also a linear regression, and the only difference between number 4 and number 8 is on number 4, the A value is the rate of change and B is the y-intercept. And on number 8, it's switched around, where the A value shows you your y-intercept and the B value shows you your rate of change. If we go down a little bit more, you notice number 9 says LN regression, and some people might think that that's linear regression as well, but actually that is the natural log regression. So we don't want to use that one for this because we're trying to find a linear regression. So I'm going to go back up to number 4 and use that. Press enter and enter again. It will give you your linear regression, your A value, your rate of change, and your B value, your y-intercept. You will also notice that you have an r-squared value called the coefficient of determination. The coefficient of determination is a measure of how well the regression models the data. The closer the number is to 1, the stronger the equation models the data. The R value is the correlation coefficient and is a measure of the strength of the linear relationship between the independent and dependent variables. If the R value is close to 1, then there is a strong positive correlation between the two variables. A strong positive correlation exists when the dependent variable increases as the independent variable increases. If the R value is close to -1, then there is a strong negative correlation. A negative correlation exists when the dependent variable decreases as the independent variable increases. If the R squared and the R values are not showing, then you will need to turn your diagnostics on. You do this by going to Catalog. If you select Second, 0, you get into your catalog. You can go down using the arrow key if you want to hit the down button about 30 times. I would suggest that you press Second, Alpha, and then this X inverse button, and that will get you down to the D's. And then from there you can press the down arrow key until you get to diagnostic on. When you get to diagnostic on, press enter and enter again, and it will show that it's done. And then when you go back and calculate your regression, it should show you your R squared and R value. The next thing you will want to do is to graph the regression equation. Now you could write down the A and B value and type it in to your y equals, but we would like the calculator to paste in the equation for us. To paste in the regression equation, make sure that there's nothing in your y equals to start with, and then we'll get out of there. Go to Stat and right arrow over to Calculate and go down to Linear Regression and hit Enter, but now don't hit Enter the second time. It will be kind of hard to not do that, but don't hit Enter the second time. Go over to Vars and right arrow to Y-Vars. We want to go to Function, which is already highlighted, so we'll press Enter. And then you can paste it into Y1, Y2, Y3. I know Y1 is open, so I'll just press Enter again. And so it shows Y1. It's going to put the linear regression in Y1. I'm going to press enter, and then it will show the information that you had previously. But then when I go into my y equals, I see that my equation is pasted into Y1. Press graph to see the regression line graphed with your scatterplot data. Oftentimes you'll be asked to interpret information from your regression equation. For example, in our example about the cricket chirps and the temperature, you might be asked, if the temperature is 95 degrees, how many times would you expect the cricket to chirp per second? To determine that, we would go to second trace, and then we can select value. It's already highlighted, so we just press enter. You will see an x equals with a prompt, which is asking you to input an x value. Input 90 and press enter. You will see an x and a y value. When the temperature is 90 degrees, we would expect the cricket to chirp about 19 times per second. Something else you might be asked is, if a cricket is making 13 chirps per second, what would you expect the temperature to be? To solve this, you would need to find the input value when you are given the output value of 13. We can accomplish this by graphing the line y equals 13 in Y2. So over here in y equals, press that, arrow down to Y2, and input 13. And press graph. Now you have two lines, and you can find the intersection of the line. To find the intersection, press second trace to get to calculate. Use the down arrow, or just press 5 to select intersect, and press enter. Your calculator will give you a prompt, first curve, and you will see a flashing X. Select your regression equation. I'm just going to arrow down here so I maybe can see my flashing X a little better. So I'm going to select that by pressing enter, and then the flashing X is on my second curve, which is actually my horizontal line. So I'm going to press enter again. And then you'll be prompted to make a guess. When this prompt comes up, I usually just press enter again. You will see intersection, and it will have an X and a Y value. In our example of finding the temperature when the cricket is making 13 chirps per second, we see that the X value is 63.12729 and the Y value is 13. This means when the cricket is making 13 chirps per second, we would expect the temperature to be around 63 degrees Fahrenheit. Finding and graphing the regression equation is a little bit of a process, and it does take several times to get the hang of it, so don't get discouraged. Pay attention to what you're doing and follow the steps here, and you'll be just fine.